Okay. M2. So this is theta 2. This is theta 1. So you studied. You have you written anything about? Have you finished this diagram?
Yes, sir.
Now write.
Yes, sir. Sir.
Right. Let us consider a body of mass m1. Let us consider a body of mass m1. Let us consider a body of mass m1. Traveling with a velocity u1. Traveling with a velocity u1. Colliding with an object. Colliding with an object. Colliding with an object. Colliding with an object of mass m2. Of mass m2, which is traveling with an initial velocity u2, which is traveling with an initial velocity u2, as shown in figure, as shown in figure.
So it's traveling with
an initial velocity u2, as shown in figure. Traveling with an initial velocity u2, as shown in figure. After collision, after making a elastic collision as shown in figure, after making an elastic collision as shown in figure, the velocity of m1, the velocity of m1 changes to v1, which makes an angle theta 1 with x-axis.
velocity of,
after collision, the object m1 traveling with a velocity v1 at an angle theta 1 with x-axis.
Sir, can you
what
please
is after
repeat?
velocity?
After collision, the object m1 traveling with a velocity v1 at an angle theta 1 with x-axis. As per diagram only I am telling you, look at the diagram and write. And the object m2 traveling with a velocity v2. Object m2 traveling with a velocity v2 at an angle theta 2 with x-axis. And right, by law of conservation of linear momentum, by law of conservation of linear momentum. Okay, there are two axes now for linear momentum, x-axis and y-axis separately. Along x-axis, by law of conservation of linear momentum along x-axis. Look, x-axis before collision m1 u1 and m2 u2, but after collision this m2 v2 makes an angle theta, so this will be m2 v2 cos theta 2. This will be, sorry, m2 v2 sin theta 2. Okay, this one will be m2 v2 cos theta 2. Similarly, this one m1 v1 sin theta 1. Here m1 v1 cos theta 1. So along x-axis, before collision, m1 u1 plus m2 u2 before collision along x-axis. But after collision, x-axis, we are getting only this. M2v2 cos theta 2 plus M1v1 cos theta 1. Similarly, along y-axis, see, before collision, no y-axis, only x-axis object is traveling. So 0. After collision, M1v1 sine theta 1 acting downward, M2v2 acting upward. So minus, they are in opposite direction. M2v2 sine theta 2. Now, when we talk about kinetic energy, by law of conservation of kinetic energy, total kinetic energy before collision is half m1 u1 squared plus half m2 u2 squared is equal to total kinetic energy after collision. Half m1 v1 squared plus half m2 v2 squared. Here we don't consider components because energy is a scalar. It is not resolving. Just total energy before collision is equal to total energy after collision. That will we have to consider.
Sir, actually, can you explain why we got 0 along y-axis?
What? I don't get you. What is that?
Sir, how did we get 0 along y-axis?
Before collision, object is traveling only along x-axis, right?
Yes, sir.
So what is y component?
Sir, 0.
0. That was 0. No y-axis. Body completely traveling along x-axis.
Okay.
Sir, for kinetic energy, there is no x and y axis.
No, because kinetic energy cannot be resolved, right? Energy is a scalar. Only vector can be resolved. What is the date today? 20?
26th.
Okay.
Sir, do we have to write the attendance in chat?
Do we have?
To write the attendance in chat?
No need. Almost theory part is over. Now we have numericals of this chapter and little more portion is the vertical motion. Motion along vertical circle. That's all. Okay. Then that topic for the exam will be over. After that, we'll have revision 1 week.
Okay, sir.
Right now. A horizontal force of numerical. Okay. A horizontal force of 15 Newton. A horizontal force of 15 Newton is required.
Sir, that derivation is completed.
That's all. Up to there only we can. Because more further we cannot go for it.
Okay.
Sir. Examination point of view, from there, very rarely question asked. One-dimensional collision only important.
Okay, sir.
A horizontal force of 15 Newton, 115, okay? A horizontal force of 15 Newton is required to maintain a velocity of 3 meters per second is required to maintain a velocity of 3 meters per second. In
To
a
maintain
body,
velocity of
3 meters per second. See, I'm writing on the board. Can you see that?
yes, sir. Yes, sir.
Every
Yes,
data
sir.
I will write on the board, you can check. So no confusion. Velocity of 3 meters per second. In a body of mass, 20 kilogram. How much work is done by the force? How much work is done by the force in 1 minute? How much work is done by the force in 1 minute? Formula: W is equal to force into displacement, Fs cos theta. Here is a horizontal force of 15 Newton is required to maintain a constant velocity. That means object goes along straight line in the direction of the force. So naturally there we can take theta 0, cos 0, 1. Otherwise theta value they will give, cos 0, 1. Then W is equal to Fs. F given but S is not given. So here we can get, look here, V is equal to ut plus V is equal to S is equal to S we need, right? We need S. S is equal to ut plus half AT square. This is a formula we can use, right? But object is going with a constant velocity. So here acceleration 0. Therefore, this component we don't have to consider. We will take only S is equal to ut. Any doubt?
No, sir.
Now S is equal to U is 3. Time 1 minute. 1 minute means 60 seconds. Substitute now. You get 180.
Sir,
Yes, sir. 180 meters.
sir, I have one
180
doubt, sir.
meter.
Sir, I didn't understand how the acceleration became 0.
Body is going with a constant velocity.
Okay, sir.
Isn't it? A body is going with a
Yes,
constant
sir.
velocity. Acceleration is 0.
Yes.
Now
Thank
S is equal to 180. Now we can put W is equal to 15 into 180. Calculate. Your answer will come 2,700 joules. This is your answer. Once you complete, please tell me and make it fast, okay?
Sir, completed.
Completed,
Over,
sir.
sir. Over, sir.
And sir, how do we consider theta as 0?
Object is a force of 15 Newton is required to maintain a velocity of 3 meters per second. That means constant velocity means object is traveling along straight line. Otherwise its velocity will change, isn't it?
Yes, sir. Yes, sir.
Sir, can we write joules per minute? If we use
No.
power,
Joules.
force into
Work is
velocity.
Sir, also you said that it's in horizontal velocity.
How
A horizontal force.
horizontal force, you mean?
Sir, in the question it's given a horizontal force of 15 Newton. So it will be, theta will be 90, right?
Horizontal force.
0, right? 0, right?
A horizontal force and object is
So
traveling with a
it will be
constant velocity.
0, right?
0.
Theta will be 0.
Okay. Next. Calculate the amount of work done. Calculate the amount of work done. Calculate the amount of work done by a laborer who carries n number of bricks, small letter n bricks. each of mass, small letter m, each of mass, see, small letter m, each of mass m, to the roof of a house, of height h, to the roof of the house of height h, like this, to the roof of height h, by climbing up a ladder, by climbing up a ladder. One person loading here, one by one. Look here, whether he is keeping the bricks in this way or whether he's keeping directly here, work done is mgh. Remember, in a conservative field,
Yes, sir.
if you go this way or if you go this way, work done is
Work done will
mgh,
be same.
isn't it?
Yes, sir.
So for taking one brick to the top of the building, here this is the ladder, there's a question. This man taking n bricks. So for taking one brick, work done is mgh.
Sir,
Okay.
actually, how do we know that it's a conservative field?
Gravitational field is a conservative field.
Okay, sir.
Gravitational field, electrostatic field, magnetic field is a conservative field. Okay. So W is equal to mgh. This is for one brick. If there are n bricks, n into mgh. Okay.
Yes,
Isn't
sir.
it?
Yes, sir.
So n into mgh. That's the formula. Next, a gardener pushes a lawn mower, through a distance of 20 meter. If he applies a force of 20 kilogram weight, if he applies a force of 20 kilogram weight in the direction at an angle 60 degree to the ground, find the work done by him. G taken as 9.8 meter per second square. So here is the force is given kilogram weight. Usually force is given in Newton. If it's given in kilogram weight, you have to convert it to Newton. 1 kilogram weight means force acting on 1 kilo body. That means 9.8. Here 20 kilogram weight. So you have to write 20 into 9.8. That much Newton. Is it clear?
Yes.
We can write 1 kilogram weight is equal to 9.8 Newton. That means it's a force acting on 1 kilo body if you're holding it. That's called 9.8 Newton or 1 kilogram weight. But when you substitute, you should take in Newton. Then work done is equal to Fs cos theta. W is equal to F is what?
196.
20 into 9.8. Okay. S is 20 meter. Cos 60. Your answer will come around 1,900 and something. You can check.
So 1960.
1960.
1960 Joule. Next. A person is holding a bucket. A person is holding a bucket. A person is holding a bucket. By applying 10 Newton force. By applying 10 Newton force. He moves on a horizontal distance of 5 meters. He moves on a horizontal distance of 5 meters. And then climbs up a vertical distance of 10 meters. Climbs up a vertical distance of 10 meters. Find the total work done by him. Find the total work done by him.
So find the total.
Work done. Find the total work done. Look here. When he's moving up to here, work done. W1 is equal to Fs cos 90. Because force upward is displacement is 90 degree, isn't it? 90 degree. Any doubt?
No, sir.
But sir, for the first 5 meters, he's moving horizontally, right?
Horizontal plane, but he is exerting force upward.
Yes, sir. Yes, sir.
So
Understandable.
Now W2 is lifting. He has to exert force in the same direction he moves. Then only he can go up, isn't it?
GH.
Okay, his movement is upward, displacement also upward. Then only you can reach here, right?
Yes.
Yes, sir.
That is mgh. So mg here is 10 because this is mg. 10 because Newton, see, unit Newton. So mg, h is how much? 10. That means 100 joule. So total work done is W1 plus W2. That means 100 joule.
Sir, how weight? So what is the weight here, mass?
Mass is not given, weight is given in the 10 Newton.
Okay, sir.
To hold this object, 10 Newton. So mass is 1 kilogram.
Yes, sir.
Sir, but in this question, we don't have to calculate the work done by frictional force, right?
Work done by?
Frictional force.
No need. They ask work done by him while going this.
Okay.
So the force he is exerting. See, he is exerting force upward, but moving horizontally.
Okay, sir.
Sir, but where is it specified that mass is 1 kg?
To lift this object, he is exerting 10 Newton force.
Yes, sir.
Then what should be the weight of the object?
10.
10 Newton.
Yes, sir.
That is mg, right?
I tried, sir. I got it.
In physics, they won't tell everything directly. You should think and find out. It's over?
Yes, sir.
Yes, sir.
Sir.
Repeat. Can I continue to next problem?
Yes,
Yes,
sir.
sir.
Yes, sir.
Next, a body moves from a point A. A body moves from a point A under the action of a force, varying in magnitude.
Sir, can you please repeat the whole question? I didn't get it.
A body moves from a point A under the action of a force varying in magnitude as shown in figure. Obtain work done by the force. Obtain work done by the force in Newton. Obtain work done by the force in Newton. Obtain the work done. Obtain the work done. The next line, force in Newton, displacement in meter. Force in Newton, displacement in meter. And diagram is given now. Draw the diagram.
Force, sir, force in Newton. Then after
Force in Newton, displacement in meter. So this is force. This indicating force. This indicating displacement. Now draw the diagram, okay? This is 0, 10, 20.
Sir, the y-axis is work done.
Force. This point is 15, middle. Here also 10, sorry, 5, 10, 20. Here this is 1, 2, 3, 4, 5. Now from 50, this is AP along 10. This is 10 to 15. All these green lines are dotted line, okay? This point is A, P, Q, R, S. How will you find out work done here? What logic we have here?
Sir, work done during a small distance. That is.
Yeah, it's a variable
then
force, right?
integrate
It's a
that.
variable force, right? Force
Yes,
is not a
Yes,
constant.
sir.
Yes, sir.
See, first force is becoming 10 Newton, then it's increasing to 15 Newton, then again decreasing to 0, again going opposite displacement, right?
Yes, sir.
So work done due to variable force can be calculated by area under the force displacement graph or integration. Here anyway graph is given, so we can calculate area under the graph. That will give you work done, isn't it?
Yes, sir.
Calculate
Yes.
area under the graph. So area of the first region, here you calculate W1, W2, W3 and W4. This is W4.
Sir, actually, force into displacement is work, right? So the slope we have we have to calculate the slope, right?
What is the concept of variable force? How we calculated work done for variable force? You turn the page to work done to variable force.
Ah, yes, sir. Understood.
Just turn the page and check. Work done due to variable forces. Area under the
Under the
force
graph.
displacement
Under the graph.
isn't it?
Yes, sir.
That's only concept. Now here, first calculate W1 as area under region AP. That means 10 into 1, isn't it? 10 joule. W1 is 10 joule. Any doubt?
No, sir.
Now W2 is equal to trapezium. Half into this smaller height is 10 plus this larger height is 15. This is 15, exactly in the middle. 15 into time 1. See, 2 to 3, it's 1, isn't it? How much answer will come? Half into 25. That means 12.5.
12.5.
Now W3 is equal to half into 15 into 1. That means 7.5 joule. W4 is equal to half into, that's also minus 15 actually. 15 into 1. That is minus 7.5 because displacement is downward. That means this area and this area are equal. That will cancel out. Then net work done is equal to W1 plus W2 plus W3 plus W4. That means 10 plus 12.5 plus 7.5 minus 7.5 is to cancel 22.5 joule. Is the answer.
Sir, can you explain this
Yes.
again, sir? I don't understand. So can you explain again?
Area under the graph here A to P W1, P to Q W2, Q to R W3, R to S W4, isn't it?
Yes, sir.
Area of this square rectangle here, area of rectangle, length into width. First I calculated 10 joule, right?
Yes, sir.
Second is trapezium, half into this smaller height, longer one, and distance between that. 1. Any doubt?
Yes, sir. No, sir.
Third one, W3, half into length into width. Fourth one, same formula. These two are equal and opposite. Equal up, this is negative side. So these two areas will cancel out. These two will be added.
Yes, sir. Okay. Got it.
Sir, could you show this by integration method?
Which one? Which one?
Sir, by integral method.
Integration method.
Yes, sir.
We cannot, because when the area
Yes,
is given,
sir.
how can you go for integration method? The area only given, right? The graph is given, so we have to use graph. If data is given, integration also we can do. That means integration f dx. First of all, we don't know whether it is a gravitational force or electrostatic force. We don't know what is it. So directly we cannot apply integration formula here. Can I go to next numerical? I think it's time. 1 minute. A body of mass 5 kilogram. A body of mass 5 kilogram. Initially at rest. Initially at rest. Is subjected to a force of 20 Newton. Is subjected to a force of 20 Newton. What is the kinetic energy acquired by the body? What is the kinetic energy acquired by the body at the end of 10 seconds? What is the kinetic energy acquired by the body at the end of 10 seconds?
A body of mass 5 kilogram initially at rest is subjected to a force of 20 Newton. What is the kinetic energy of the body? So kinetic energy formula is half mv squared, right? Half mv squared. Now we need velocity.
Yes, sir.
Velocity is equal
Yes,
to
sir.
u plus 80. But we need acceleration. Force is equal to ma. A is equal to force by mass. Force 20 Newton, mass 5 kilo. So 4 meter per second squared. So V is equal to U0 plus 4 into time. What is the time? 10 seconds, isn't it? So 40 meter
sir.
per second. Then kinetic energy is half into M5 into 40 into 40. Final answer will come 4,000 joules. Finish it.
Sir, it should be kilojoules, yeah.
Which one?
Kilojoules, yeah. It should be
Kilo?
kilojoules because mass is in kg. So it should be kilojoules.
How kilojoules? Kilogram meter per second. Why you are telling kilojoules? W is equal to force into displacement. So Newton meter or joule, work done. Why mass is kilogram, then kilojoule come? Then let me ask you a question. F is equal to mg. 1 kilo into 10. Can you say kilonewton?
No, sir, no.
We can make it 4 into 10 to the power 3 kilojoule. Like that you can write. If you want this, you can write this way. 4 into 10 to the power 3 joule and 4 into 10 to the power 3 kilojoule. Like that you can write if you want. It's not because of mass is kilogram, we are writing kilojoule.
Okay, sir.
Okay. Next question. A toy rocket of mass 0.1 kilogram has a small fuel of mass 0.02 kilogram, which it burns out in 3 seconds. Starting from rest on a horizontal smooth track. It gets a speed of 20 meter per second. After the fuel is completely burnt out. What is the approximate thrust? Of the rocket? What is the energy content? Per mass of the fuel? What is the approximate thrust of the rocket? Next question. What is the energy content per mass of the fuel? Ignore the mass variation of the rocket.
Sir, can you repeat the second
burning.
point? Sir, can you repeat the second point? What is the energy?
What is the energy content per? What is the energy content per unit mass of the fuel? So this is 0.1 kilogram mass of the rocket. Fuel is 0.02 kilogram. Okay. While it is burning, this rocket will move. The velocity of the rocket is given as a rocket of 0.1 kilogram has a small fuel of mass 0.02 kilogram, which it burns out in 3 seconds. So time 3 seconds, it gains a velocity of 20 meter per second. What is the thrust? That means this fuel will burn, a force will develop, right? With how much force?
Yes, sir.
Same way it get a reaction. That's the thrust. So that we can get F is equal to Ma. M is how much? 0.1 kilogram into, why I'm not considering this fuel? Because fuel keep burning. And they said ignore the small variation of the fuel. And the question is clear. That's why the fuel I'm not considering. So rocket 0.1 into acceleration of the rocket V minus U by T. Initial final velocity of the rocket is 20. Initial velocity 0. Time 3. So here we can say F is equal to 0.1 into 20 by 3. So that answer will come 2 by 3. That's equal to 0.66 Newton is the thrust acting on the fuel, this rocket. That's the first answer. Have you finished?
Yes, sir.
Yes, sir.
Now in the second question, 1 kilogram of this fuel, if you are taking, how much energy will be there? Energy content per unit mass of the fuel. That's the second question. We know the kinetic energy of the rocket is half mv squared. Half mv squared. Okay. Half into mass of the rocket is 0.1. Velocity is 20 into 20. That means your answer will come 20 joule. Isn't it? This will be 10 and answer will come 20 joule. Okay. From where this energy gained? Who supplied this energy?
Fuel.
Burning of
Energy of the fuel only converted into kinetic energy because energy is conserved. Energy cannot be created nor be destroyed. It can only convert. Now we can say, look here the logic. 0.02 kilogram of fuel can give an energy of 20 joule, isn't it?
yes, sir.
Therefore, 1 kilogram contains how much energy? 20 by 0.02, right?
Yes.
Joule per kilogram. So this will be now thousands joule per kilogram. That means 1 kilogram fuel, if you're taking 1000 joules, it will be there, energy. Is it clear?
Yes, sir.
Yes.
Next question.
Sir, can you go
Again,
back,
let's go
sir?
back. Yes, sir. Finish.
An electron and a proton are detected. Electron and a proton are detected in a cosmic ray experiment. Electron and a proton are detected in a cosmic ray experiment. the first with a kinetic energy of 10 kilo electron volt. 1 electron volt is 1.6 into 10 to the power minus 19 joule. An electron and a proton are detected in a cosmic ray experiment. The first with a kinetic energy of 10 kilo electron volt and the second with a kinetic energy of 100 kilo electron volt. Which is faster, electron or proton? Which is faster, electron or proton? Obtain ratio of their speeds. Obtain the ratio of their speeds. Mass of electron is 9.1 into 10 to the power minus 31 kilogram. And mass of proton is 1.67 into 10 to the power minus 27 kilogram. Now let us see. Kinetic energy of electron is half into mass of the electron and velocity of the electron squared. Kinetic energy of proton is equal to half into mass of proton and velocity squared. Now kinetic energy of electron divided by kinetic energy of proton is equal to half MeV squared divided by half MP Vp squared. Half of cancelled here. Then here kinetic energy of the electron is 10 kilo electron volt. This is 100 kilo electron volt. That's equal to Me by Mp into V by Vp whole squared. This is now 1 by 10. KeV cancel 1 by 10. That's equal to Me by Mp into V by Vp whole squared. Now V by Vp whole squared is equal to 1 by 10 of Mp divided by Me. Okay, finish up to there. Finish up to here. And we can calculate V by Vp ratio is equal to 1 by 10 into Mp by M. Oh my God. This is V by Vp is Mp by Me, right? Isn't it?
Yes.
Mp by Me. Root. Now substitute. V by Vp is equal to 1 by 10 into what is Mp? Mass of proton. What is mass of proton?
1.67 into 10 raised to minus 27.
1.67 into 10 to the power minus 27 divided by, this is 9.1 into 10 to the power minus 31. Solve it.
Sir, that's enough, sir.
So if you're solving it, your final answer will come V by Vp is equal to, you can check it later and tell me, this will be 13.25. This is the ratio. Here, velocity of the electron is greater than velocity of the proton. Because velocity of the electron is 13.25 of velocity of proton. Next, a bullet weighing 10 gram. A bullet weighing 10 gram is fired with a velocity of 800 meter per second. Is fired with a velocity of 800 meter per second. After passing through a mud wall, MUD, mud wall of 1 meter thick, its velocity decreases to 100 meter per second. Find the average resistance. Offered by the mud wall. Find the average resistance offered by the mud wall.
Sir, here the average resistance is meant as the work done by the mud wall, right?
Yes. Suppose this is the mud wall. Total length of the mud wall is 1 meter. A bullet of mass 10 gram, okay, hit here with a velocity of 800 meter per second. While this is traveling through the mud wall, this mud wall offers the resistance, opposition factor. Finally, this velocity comes to 100 meter per second. So here kinetic energy of the bullet changed. By work energy theorem, the work done, force into displacement is equal to change in kinetic energy. That means final kinetic energy half mv squared minus half mu squared, isn't it?
Yes, sir.
Work energy theorem. So here force we have to find out. Distance is 1 meter. So equal to half m, let us take outside, v squared minus u squared. Half into mass is 10 into 10 to the power minus 3 gram into kilogram. V squared is 100. The 100 squared, isn't it? 100 squared, that is v squared, minus u is 800 squared. Find out answer. Final answer will come minus 3150 Newton. This will be the final answer. You must check. Then tell me if any difference in the answer.
So why 10 raised to 3 is here?
Huh?
10 raised to minus 3, why?
Gram into kilogram.
Oh, yeah.
Sir, the minus 3, 10 raised to minus 3 is coming from?
Gram to kilogram.
Mass is 10 gram.
Yes, sir. Yes, sir. Conversion. Okay, sir. Understandable.
Next question. A shot is traveling at the rate of 100 meter per second, is just able to pierce, P-I-E-R-C-E, pierce means penetrate. Just able to pierce a plank means wooden plank, pierce a plank of 4 centimeter thick. 4 centimeter thick. What velocity is required? What velocity is required to pierce a plank of 9 centimeter thick? To pierce a plank of 9 centimeter thick. So here S1 is 4 centimeter here. 4 centimeter. There is another plank S2. This is 9 centimeter. Same material. So force is same here, right? F into S1, F into S2. If the density of the material is same, the force which is opposed will be same. Only distance covered only will be different here. This is hitting with 100 meter per second here. Okay, with 100 meter per second it hits here. Just to pierce, so here velocity becomes 0. Here with what velocity, that means here we can say V1. This is V2. With what velocity it should hit here, so that this can just penetrate through this? That's a question. So first let us write the formula for first one. F into S1 is equal to change in kinetic energy. Half final kinetic energy 0. Final kinetic energy 0 minus half into M1. Mass is same, mv1 squared. There's a formula for this plank, isn't it? Now for this plank, F into S2. Final kinetic energy again 0 minus half into same bullet we are hitting here. Mass into V2 squared. Now if you divide these two, F will cancel. 0, 0 anyway gone. Half of cancel, cancel. Then S1 by S2. S1 by S2 is equal to V1 squared by V2 squared. Then V1 by V2 is root of S1 by S2. Clear? So here, what is V1? 100. V2 we don't know. S1 4 into 10 to the power minus 2. S2 is 9 into 10 to the power minus 2. So we can write here, that is 100 by V2 is equal to 2 by 3. Or V2 is equal to 300 by 2.
Hello.
That's equal to?
That's
1.
matches.
Isn't it? Was that? Per second. These kind of numericals definite from this area, this chapter.
So what is 0 in this case?
Final velocity.
Okay, sir.
Question, it is just able to penetrate. Just able to penetrate means kinetic energy becomes 0 here.
Yes.
So your main idea, work done is equal to change in kinetic energy. Next question. When a 40 kilogram boy climbs a hill
A 40 kilogram boy climbs a hill. And his potential energy increases by 9.8 into 10 to the power 4 joule. Increases by 9.8 into 10 to the power 4 joule. What is the height of the hill? What is the height of the hill? So potential energy is equal to mgh. 9.8 into 10 to the 4. That's a change in potential energy. Mass of the boy, how much? 40. 9.8 into h. We can find out h. So h is equal to 250 meter.
Yes, sir.
Next question.
Sir, wait, sir. Finished.
Done, sir. Completed.
Finished, sir.
Sir, you are
Sir, you
muted.
are muted, sir.
The bob of a pendulum, a bolt of mass, a bolt, B-O-L-T, bolt of mass 0.3 kilogram falls from the ceiling, of an elevator, falls from the ceiling of an elevator, moving down with a uniform speed, that elevator moving down with a uniform speed of 7 meters per second. If the bolt hits the floor of the elevator, and does not rebound, it means what? Complete energy converted into heat and sound. Does not rebound. Height of the elevator is 3 meters. This is 3 meters. What is the heat from the impact? That means complete potential energy will change into heat. What is the heat from the impact? Would your answer differ? Would your answer differ if the elevator is stationary? So first let us calculate heat generated from here, okay? W is equal to mgh. This is the potential energy it has, EP. Now mass of the bolt 0.3. G, let us take 10, okay? H 3. So here how much answer will come? 9, right? 90. 9. Isn't it? 9 joules, right?
Yes, sir.
Yes.
This is EP. Now, if it come and hit here, same amount of energy develop in the form of heat. So heat generator is 9 joule. Okay.
Okay, sir.
If it is stationary, it doesn't make any change. But if it's accelerated motion, it will change. But stationary and rest almost same effect. Is it over?
No, sir.
Yes, sir, it is over. So what was the last statement? That was the moving and uniform speed of elevator.
See, an object at rest. Say, for example, an aeroplane at rest, aeroplane going with a constant speed, same effect. That's what on the air, when aeroplane going with a constant speed, you can move in out and just like rest. So it doesn't make any change in the weight when it is falling down. But if
So
it's
our
motion,
answer won't vary it, yeah.
huh?
Our answer won't change, yeah, if it is
It
stationary.
won't change. It won't change because constant velocity and state of motion have same effect. Next, the bob of a pendulum, the bob of a pendulum is released. The bob of a pendulum is released from a horizontal position. The bob of a pendulum is released from a horizontal position from the horizontal position A as shown in figure. As shown in figure. That means from here it is brought here and kept initially. So this length and this length are same, isn't it?
Yes, sir.
Yes, sir.
So what is the height this pendulum is lifted? Which height it went?
Sir, L.
So L, sir.
That is equal to L, isn't it? Length of the pendulum. Agreed?
Yes, sir.
Yes, sir.
The bob of pendulum is released from a horizontal position A as shown in figure. If the length of the pendulum,